Okay, great. And we'll just wait for a minute or so, and then we'll start. All right, welcome to the new live event. This time, Dr. Yu and Dr. from SRC to give a on how to attract funding from SRC. So both of us have been extensively involved in the SRC, so they know a lot about it. And I'm pretty sure your presentation will provide a lot of information about it on the mechanisms. All right, without the introduction, I'll pass it over to Dr. Joyner and Dr. Yu for the detailed presentation. All right, so let me pass it over. Okay.
Hey, thank you, Professor Shi. This is Bill Joyner here along with David Ye. We're here at SRC, which is headquartered in Research Triangle Park, North Carolina. We're happy to try to talk about funding in the SRC from the CAD and test area and how to get it. I know there are several questions about what funding is available, and we'll try to answer that along with what are the particular topics our member companies are interested in, and how you might improve your chances of doing that. I'm listed as they're a Senior Director Emeritus, which I don't know if it's my correct title, but I retired from the SRC on January 1st, and I have a new job. This is my grandson, who is named after me, so this is my new job to support him and give him all the funding he needs and milk. So thanks very much. If you're not that familiar with SRC, we are a member-based, member-driven organization, a not-for-profit organization that's supporting university research in a number of areas worldwide. We have, at any given time, several hundred universities that we support in different countries in the U.S. and also in Asia, Europe, the Middle East, and the Far East. This is a list of the current the current members. Some are members of particular parts of SRC, but these are the companies that are participating now in SRC. Some are long-standing members of SRC, which was founded in 1982, and some are new members, which we'll try to address in a little bit. I'll turn this over to David now to talk some about the SRC model and how SRC is structured.
Right. Thanks, Bill. The SRC model is built on member company dues, government agency funding also, and is a mechanism for trying to collaborate on a public-private partnership in pre-competitive research areas. So as this chart shows, we pool money together and then we solicit research from what we think are the best universities to generate research results, intellectual property, and talent for the workforce. The ideas make it into commercialization and is transferred into the companies and the community at large. This is a snapshot of the current state of SRC research programs. Bill and I have spent most of our time here at SRC in the global research collaboration piece, which is in the red box on the left. The StarNet program is one that is aimed towards early research on key long horizon challenges. The Nano Electronics Research Initiative is looking beyond CMOS as the next switch in associated architectures. And then we have an emerging research programs that we're actually not going to talk too much about today. Now, we're highlighting some new programs that SRC is currently working on, namely JUMP and NCORE, where those are now open for competition. And all solicitations essentially are listed under the SRC website under this URL, www.src.org/compete. So if we go to the next slide here, we have something called the New Science Team. That's what NST stands for. And that is essentially the steering team that is developing both JUMP and NCORE. So JUMP is jointly funded with DARPA. That's called Joint University Microelectronics Program. And the themes of that particular effort are listed there. There's 6 particular themes. And you can see that it spans the whole applications to the materials span in the little graphic there. The NCORE program is funded with NSF and other government agencies and is looking at those 5 particular themes there with a similar graphic in terms of where it is emphasizing research. One thing that we do want to mention here is that single investigator white papers as well as center proposals are solicited and are wanted. If people that are interested go to the URL that was listed in the previous slide, there's more information about making a submission and things like that. So in the past, many people may have thought, well, they don't want single investigator submissions here, but this particular program, these particular efforts, they are specifically wanting single investigator white papers, okay? So I wanted to highlight that as something that is actually different about this program right now. So moving on to the next chart are the GRC thrusts, and we have a number of thrusts here. The ones that are probably most interesting for this audience, I would imagine, are the CAD thrust with a little box around it, and then the Trustworthy and Secure Semiconductors and Systems, called also T3S, that also has a little box around it. Now, all of these research thrusts will have solicitations at some point, and these 2 areas are set to have solicitations that open in October of this year, which is not too far away. The way that these particular thrusts run is that the Technical Advisory Board will generate a needs document, and that will be published, and then the submissions should address needs that are described in those needs documents. To see past needs documents, there's a URL listed right there if people are interested in looking at where the member companies have had past interest. So this is a very simple chart, and I'll let Bill explain the idea behind it.
Well, this people have asked the question: is the CAD area being de-emphasized at SRC, and what's the story about future funding in that area? While it's unclear we can answer questions too far in the future, you can see from the previous slide that when I came to SRC 19 years ago, I think we had 5 science areas, and now there are, I think, 11 areas here. So CAD and test is still one of the larger areas, one of the largest areas in the GRC for research. So that's not changing. What's changing is there are a lot more areas. So if you think of the resources SRC has for this program, which we get all from our member companies, you might think of them as this pie. And our members, this is a member-driven, as it said in the other chart, a member-driven organization. And you can think of our members as having these knives to divide up the pie based on their mutual interests. All the member companies, Intel, Texas Instruments, IBM, Global Foundries, NXP, all are dividing up the pie. So in order for the CAD and tester, in fact, any of these areas to grow, the thing is we need to grow the pie. We need to get a bigger pie. We don't want to keep just cutting up the same pie into smaller parts and produce smaller programs that may not be viable and stand on their own. So that's what this chart is meant to introduce. But I do want to emphasize that these pieces of this, but this is obviously a picture I stole from somewhere on the internet, and these pieces of the pie do not represent the science areas. But if they did, the CAD and test is one of the bigger areas in those 11 thrusts. So how do we grow the pie? And we've made some progress in growing the pie. One way is to get more members. We need to get additional members, and we have in the past 2 years gotten several additional members to contribute, some to particular thrusts, some to the whole, all the thrusts. Most recently, TSMC, Qualcomm, Analog Devices, ARM, and Microsoft have become members of some of the programs that you've seen on the other chart. So one way of getting a bigger pie is to get more members and get the dues from those members and their contributions. The other way of increasing the pie is by partnerships, and David talked some about that on the previous slide with the JUMP and NCORE programs. We have partnerships with Defense Department, with NIST, with National Science Foundation, and our goal in all of these partnerships is to get substantial contributions from these government agencies, but still give our member companies a say in what research gets funded. Those partnerships exist not just in those JUMP and NCORE programs that they have, but also in some of the work, some of the projects that these different thrusts that we saw on the previous chart are doing. And this logo here that if you're very old, you remember this looks like the civil defense air raid kind of thing, but it's emphasizing the partnership we try to foster at SRC between industry, government, and academia, forging durable memberships from all those agencies. I do want to point out we have had several joint programs with National Science Foundation, some of which are ongoing. Those have been very good for our members in that we've gotten different kinds of contributions from the members, sometimes two from the government, sometimes 2-for-1 contributions from NSF based on what industry contributes. And we've had a substantial say in helping select the projects. We do have to, of course, go through the regular NSF process. That if you're faculty members who have submitted proposals to NSF, you're familiar with that. But some of those have been joint programs with the SRC, and it was at NSF not so long ago, and one of the division directors emphasized that they still want to have a good relationship with SRC and a relationship with industry. These are going back to 2001. Some of the programs that we've had. The first one since I was here was Mixed Signal Electronic Technologies. There was one called Multi-Core Design and Architecture. We had Failure Resistant Systems, and there are two that are ongoing now. We have one called STARS in the security area, Secure, Trustworthy, Assured, and Resilient Semiconductors and Systems, and one called E2CDA, Energy Efficient Computing from Devices to Architectures. Those are going on now, and periodically, I think annually now, have received, have opened the window to proposals.
Yeah, I wanted to mention that in the GRC piece of SRC, we have a good relationship with the National Science Foundation, and we continue to explore ideas for future joint programs. And the participation of multiple thrusts, and in the past case, the science areas, was a way to have a solicitation that was broad and addressed needs in several different areas from both the sides of the member companies and from the National Science Foundation's view. I think these programs help the NSF engage in research that is translational and impacts industry. So we hope to continue and have new programs in the future.
I wanted to point out the SRC, this is tooting the horn of SRC, but the 2005 National Medal of Technology, which I think was not awarded until 2007 or so, was given to the SRC as a great example of a consortium to invest in the semiconductor industry. This was given by the President of the United States. This is now 2 presidents ago, President Bush with our CEO at the time, Larry Sumney. Both of these have left their CEO positions, but Larry shook hands with the president. He was given the medal, and in the video, which you could see, there was this whispered exchange here, which we don't know what was said, but we like to think Larry was asking the president for more money for CAD research. So we hope that continues with the current administration. Let me let David now talk about some of the emphases that our members see in.
Right. This particular chart, it's a word cloud of different descriptions of research needs that the member companies have supplied. In preparation for this particular seminar, Bill and I sent an email out to the Technical Advisory Board and asked for a list of current research needs. This is outside of the normal solicitation process, and so we think that this is a fairly fresh information. And the frequency of the words makes the font size bigger here. And I think you can see that test and verification, simulation are things that stand out. There's a number of other things that stand out too that I'll try to describe in subsequent slides. But I think the core areas of the CAD and test thrust are still well supported within the member companies. We have here a number of things that are perhaps a little bit newer. There's a large effort in automotive in a number of member companies. Security and design for security is something that is on the minds of the member company representatives. That's somewhat addressed in the T3S thrust. It's also, I think, somewhat addressed in the test thrust, in the verification thrust. And simulation, I think, was a word that I was glad to see in terms of trying to do more with CAD tools. And so that, I think, is an interesting thing for the academic community, that the member companies are still very interested in simulation of various types. In the test and testability, so I think that previous graphic was sort of interesting to look at. In the test and testability space, I've sort of highlighted just a few of the things the member companies are interested in right now. And then this is not a comprehensive list, but I think hopefully it is explanatory for those that work in the field. I think RF and millimeter wave test is still very wide open. There's a number of things that the member companies are trying to do right now, particularly a CMOS millimeter wave design, for instance, and to roll out products in that particular space for certain applications. The test and the verification of that is very difficult. I think reusable test structures for IP protection was mentioned. I'll just highlight a few of these things. Coverage for safety and fault tolerant systems. I think especially with automotive as an end market, fault tolerant, reliable, and safety and security are big concerns. Part of that is driving DPPM to DPPB levels, and there's a number of things that impacts. Obviously, I think those in the test field are very aware of that kind of thing. Along with automotive comes more extreme environment testing and defects for emerging devices, accelerated stress testing. In-field testing and self-trimming are areas that the members have interest. And testing of security properties is something that has risen to the forefront. Test generation for power mode transitions. These days, in many different things, there's a multitude of power modes, and testing the transitions in all the different cases can be very challenging. Another thing that the companies mentioned in the test and testability space was LBIST that has power issues for at-speed testing. And then another thing was statistical techniques and data analytics to supplement electrical tests. So a few subtopics there: learning engines built into die, neural network usage, a better prediction, and design flow, progress, and confidence as areas that potentially have interest for the member companies. Self-test techniques for logic, memory, analog, and RF. I think this continues to be something that the members have interest. And so this is, I always have to temper this self-test thing with topic with the notion that, well, the member companies really have to turn a product out. An area is important, and the power and everything like that is very important too while we're doing the self-test. Moving on from test and testability to this security area, I phrase this as DFX, where X equals security. I think some of the things that the member companies mentioned as being important right now are high-speed simulation of security attacks, whether it be side-channel fault attacks or row hammer type attacks, for instance. Not necessarily a complete or comprehensive list, but some of the things that were specifically mentioned. Co-verification of security policies and protocols. Okay. Computation of coverage, or computing coverage diagnostics for safety and fault-tolerant systems. The notion of coverage, I think, is still immature in this particular space. Trojan logic detection by simulation or formal methods, functional BIST for secure elements that are not LBIST or SCAN-based, and a formal verification of a wider set of security policies. Reusable test structures for IP protection and reprogrammable secure IJTAG. So I think if we some of these titles are more familiar for the way that the CAD-T area is divided, and it's divided into test, verification, and system logical and physical design. So I followed that convention in these particular charts. In this particular space, which includes a lot of simulation, the circuit simulation space, including RF and millimeter wave, is one that advances would be very beneficial from the member company's viewpoint, especially with better distributed component modeling. It includes antenna and transmission lines. Something else that's interesting for the member company is more multi-rate simulation for mixed signal blocks, including data converters, phase lock loops, and DC-DC converters, and things like that. Circuit variation modeling and efficient simulation. We're talking about something that's way more efficient than Monte Carlo, for instance. Moving on, aging and reliability simulations are interesting for the member companies because of the increased emphasis on reliability of end products, especially in extreme environments. Coupled thermal and electrical simulation, I think that goes along with the whole reliability thing and trying to optimize and maximize the performance and minimize reliability of effects. And this one actually surprised me a little bit, but digital timing was still very key for member companies. Better accuracy and more efficient analyses for digital timing. I think as complex as chips are these days, the member companies feel that they're still leaving a lot of margin on the table when they're doing straight digital design. And the last one mentioned here is effective triage techniques for functional post-silicon bugs. Having post-silicon validation and having a customer return, it causes much angst in the member companies, and better ways to have triage techniques for some of these issues, I think, would be very beneficial for the industry.
I think you see from some of these, some of the old standards that you think have been displaced, or the things that problems have been declared solved, nevertheless still continue to be of interest to the members, like circuit simulation and circuit models and so forth.
In the verification space, which traditionally has emphasized formal techniques, formal methods still is an area that the member companies derive a lot of benefit from, including the traditional SAT, SMT, model checking, invariant generation, etc. But moving into new areas, is there a way to bring formal methods to bear for security or analog mixed signal or power management or performance validation? These are questions that I think the member companies think that the academic community can help address. And then following that, metrics for verification quality. I think there's an issue with, is there a way to have some sort of common metrics for both formal and dynamic verification? And is there a way for metrics to, and verification quality, verification quality that comprehend different use cases for IP, SoC, and platform? Bridging the gap between pre-silicon verification to post-silicon test and validation, I think goes along with the one of the items mentioned on the previous chart. Leveraging component level verification to the system level, that's to help address the complexity issue of designs these days. And is there a way to leverage that so that the whole system verification problem can be broken down into a more of a divide and conquer approach? Industry trends driving the need for more robust verification and test. This is the thing that I was mentioning earlier about automotive and more extreme environments, for instance. And then the last thing I wanted to mention for verification is the design complexity increases, and I wanted to highlight that in big digital design, there's more analog content, and in analog design, there's more digital content. And you know, each of those is mixed signal, obviously, but approaching it from the big digital side or the analog side it leads to potentially different approaches that may be developed.
So we're happy to take questions at the end of this, but we wanted to try to give some additional pointers in addition to the technical content of the proposal, as to what should what are some of the things that would help white papers and proposals be well received at SRC. There's one problem that sometimes exists, that if you're a faculty member and you're working closely, as shown up in the upper left here, working closely with a colleague and one of our members on the bottom, that's very good. That's all very good that kind of industry connection is being made. There are industry problems that you may see and so forth. That's good. On the right-hand side, SRC and the person of David at the top there is also in touch with our industry technical advisory board members. So we have a strong connection there. Often one of the problems is that your colleague in company A may not be in touch with the SRC tab member from company A. Your colleague may not even know about SRC. So it's important when you submit white papers and proposals to make sure that connection gets made, so the person over here on the lower left is communicating with the tab member in the lower right, so that connection can be made. And when this voting process happens and proposals are evaluated, they will know that there's a productive relationship already there, and that the company would get a lot out of continuing that with an additional project. There are several questions that should be self-explanatory when the SRC proposals go in and just to talk about some of those. There's a question about, are you aware of blocking background intellectual property that's needed to practice the results that will not be made available royalty-free to SRC members? There's an obvious answer to this question that the SRC is looking for, because our member companies want the freedom to practice the results of the research that they sponsor. On the one hand, you may think that if there's a blocking background intellectual property, the members may want to negotiate with you about that in order to get the research done. In reality, the members have many proposals to choose from in making these decisions. So if there are things that look like they may have intellectual property complications, members will most likely go on to the next project in line rather than to open a discussion which may be more complicated. So that's the correct answer to this question, which appears on the SRC proposals. There are also some instructions with white papers that says, please use fonts of 10-point size or larger. I'm not even sure this still is contained in there. And proposals should be for no more than X dollars annually. If you've ever been on NSF evaluation panels, you know that if proposals are asked for to be no more than, for example, $500,000 for 3 years, they all come in at $499,999.50 or something like that. That's why in most cases we purposely do not. Not only do we not have a limit of the proposals, but we emphasize in the solicitations that the cost of these is one of the factors that our members take into account. Our members are not trying to take undue advantage of faculty, but they do want to see their contributions to research go farther. This is you're just supposed to squint and look at that, but if you submit a white paper on the left that uses the minimum size font with no spaces and no figures in anything, this is harder to digest than one on the right, which I'll pass by quickly because I think these were actual white papers. That looks like it's more readable to the evaluation people. Industry interaction. There's some things that are good and some things that may not be as good. If you somehow in your white paper and proposal say you're working with so-and-so and so-and-so and such people among your member companies, I think we illustrated before, that's a good thing. I think the fact that you're working with somebody on member company A is also a good thing for member company B, because that indicates that you're willing to work with industry. You have industry connections before. Maybe you've had previous sabbaticals or other things at industry. All these are good things in terms of getting a white paper to get the good reviews. Although it's all our understanding that we know that you have to support yourself and your students, so we know you're working with other companies and other agencies, some of which may not be associated with SRC. Everybody understands that. I mean, one way of looking at that is that it helps our members get additional leverage. But I would say it's not a good idea to emphasize. I'm working a lot with some other company that's not a member of SRC. You can go to the SRC website and you can see the members who are on these evaluation boards and committees, and you can see who the members are.
And the member company representatives typically that contribute to the needs document are listed. And so that gives you a good clue as to who's interested and who's participating in that particular area.
If it's maybe even worse if you say, or it's the case that my students are all joining these competitors, my students are all joining a startup. One of the values our members see in SRC funded research is to have a way of attracting students to their companies, and they would like to see that. We added this yesterday. Even worse is if you say I need to have some additional royalties for undisclosed BIP. The basic attitude of our members, whether it's totally valid or not, is we're paying SRC substantial amounts of money. And we want to fund the research we want, and we want to have access to the software or other techniques that are developed because we want to use them within our companies. There often is a question, I think, with the tightening which we showed in the picture of the pie. Why should I work with SRC? Obviously, you would like to get funding. We know you have obligations to students and to your research and want to support that. But we think there are other good reasons to work with SRC. I think it is not the case anymore. We have open solicitations. It's not the case anymore that we're just funding the same people, I don't think, again and again. Although I used to have a picture. David and I are really agents for the members. David's an agent for the member. I'm a retired agent for the member. NSF, Shankar Basu is an agent for the taxpayers of the United States. But there are good reasons, I think, to work with the SRC and the member companies to get interaction with industry research, which may be on the cutting edge, to get exposure to industry challenges. The challenges you see, you would like to see what the industry sees as challenges, so you can be working on them, so that your students can be working on them and find positions in these companies and so forth. You'd like to be able to get access to real designs. We encourage that with the member companies. Often member companies have given sanitized designs to faculty work on. So companies have given real designs subject to non-disclosure agreements to faculty so that they can get working on real problems. We still encourage publication. There's always a way to publish that material so long as the designs aren't revealed. But I think that's a reason to work with the SRC and its member companies. I mentioned that we have jobs and internships for students. They hire, those that are hiring do hire students from SRC. The students tend to have a leg up if they've been working with the member company challenges, if they have had internships and so forth. And we do have individual connections, and also through a couple of SRC programs, try to provide lower cost access to fabrication and advanced technologies from our members. I did want to point out, SRC is not the same as NSF. Members are looking for the things listed on this chart, that some of which were there before. What are the connections you have with industrial contacts? How are your tools and techniques better than what's available now commercially? What's the comparison with what exists now? What is the method for transferring university work into industry? What students are going to be available to come and work in my company and for the summer or permanently after receiving a degree? Is the work meeting industry needs? What is the methods you're proposing cost effective? And often many companies have their own research efforts, but they're often interested in what are we missing? Is there something that's going on in the university environment that we should be worried about, that you can tell us we should be worried about, but we're not worrying about? They would like to see work like that. This is just I came to SRC 19 years ago this month, and my manager was Ellen Yaffa, shown here at IBM. And she said, the faculty are all going to love you when you go to SRC, because you're going to give them all this funding, and it's going to be great. They're all going to love you. And I think that is part reality. I think I do have good relationships with faculty, but in reality, if we solicit for white papers, and we advance a third of those white papers to ask for full proposals, and then we fund a third of those, the number of proposals funded is probably 10% or less than those submitted. So if you went by this formula, the faculty that love me would be only 10%, and those that hate me would be 90%. This is just a joke, and it's not meant to imply any hatred between me and the faculty members. So, predicting the future, I think we've seen some questions about, how should I plan what I'm doing over the next couple of decades, and the future is very hard. This quote is often attributed to Yogi Berra. Prediction is very difficult, especially about the future, but it's It's actually said by Niels Bohr. Einstein said, I never think of the future, it comes soon enough. Dan Quayle, the future will be better tomorrow. And Dan Quisenberry, who was a pitcher for the Kansas City Royals, I've seen the future and it's much like the present, only longer. So we thank all of you for participating and we'd be happy to answer any questions.
All right, thanks for the excellent presentation. So the audience have any questions, type them in the link I sent to the email, so I can relay it to the speakers. Right. So while we're waiting for the questions from the audience, we have for so what do you think about the, like we heard about the industry, like many topics, learning, along that direction. I think the SRC will shift a little bit, focusing on those kind of areas, or it will still be kind of way, that you discussed in the presentation.
I don't think that we quite made out what that question was.
Well, basically, how SRC the recent trends about learning and machine learning, kind of area in the industry.
Yeah, that's a nice question. I think machine learning is something that has been applied in several different areas already. The one that pops up to mind for me right now is in the test area. Several researchers have actually received funding to look at certain types of test problems and bring machine learning algorithms to try to solve those issues. So machine learning is an area that I think is not necessarily brand new to SRC. I think it will continue to become more important as machine learning and more complex types of machine learning algorithms are developed. I think there's a very interesting question about unsupervised machine learning that's lurking out there in terms of how do you verify that, how do you test that, and trying to make sure that that it's not very brittle in terms of, well, how did the algorithm actually go in that? Why did the algorithm go in that direction versus some other direction? So those are some things that in terms of interest areas looking out another, for instance, 10 years, I think there's going to be a lot of opportunity for research in that particular space.
All right, cool. Thanks for the okay, audience, do you have any questions? This will be your last chance to ask. Put it on the I'll just probably wait for 1 or 2 minutes to see if there's any question from the audience before I let you.
Maybe I can say something about the JUMP program, because that's I've gotten the question about single investigator in a number of different forums. And while I'm not actually managing the JUMP program, and I'm not really that close to the JUMP program right now, several faculty members have asked me, so how would that work? You're asking for center proposals and single investigator proposals, or submissions essentially in this program. And I think what the way that's envisioned is that there will be a number of interesting center proposals for the member companies to evaluate. And in parallel, there will be a number of very interesting white paper submissions. And the idea is sort of to take the top ranked white paper list and sort of make that available to the top level or the center proposers, with the suggestion that, well, these are some areas that the member companies think that perhaps are not covered very well in the current center proposal. That might be consideration as it gets developed further, for instance. Okay.
Okay.
So that's one of the reasons that I think this particular effort, a single investigator white papers are desired. Okay.
Okay.
And I think on this previous slide is the URL pointing to how you can submit them.
Right.
Okay. I think we have a question. Okay. We have one question from the audience. What is the expected funding rate for the jump center?
Well, it depends on how many submissions are there. It's an excellent question, but it's not known.
Okay. Do you have any estimates for that? Based on the history kind of data?
Well, this is the first time that single investigator white papers are asked for, so that would skew the count somewhat, I would imagine. The center proposals, it is, I think that it's still following the white paper and proposal process. So the generation of a center submission essentially is a lot of work. I have no idea how many centers have been submitted in the past. I did not look at the most recent StarNet submission process. So quite frankly, I don't actually remember from the previous Focus Center Research Program how many submissions there were total. I think that there are supposed to be a number of interesting topics there that would lead to a number of centers being funded. I think the nice thing about this particular solicitation is that for the single investigator out there, you don't have to be in a center proposal to actually wind up with JUMP or NCORE funding. I know I'm not really answering the question, but I think that's the best I can do right now.
Yeah, okay. One more question from the audience. So, does SRC actively participate in NSF panel for the joint program?
Is SRC actively
participating in the NSF panels for the joint SRC NSF programs?
Yes, when the let's see, for these solicitations, I was part of essentially the first three. Okay, so I can speak about those. Member company representatives helped define the program with the call for research. They served on the panels, and then they evaluated all the submissions essentially. So member company representatives did participate in the evaluation of the research. So I think on the STARS program, this particular one, it's been one of the beauties of that particular effort is that there's a yearly solicitation. So there's a consistent investment in university research in this particular area. And so we've had the opportunity to build quite a nice program in the security area already, in the hardware-based security, that is. And member companies hold research reviews on that particular area and have helped evaluate the research.
I see. All right. I think that's all the questions from the audience. Thanks again for the excellent presentation. I think we'll learn this presentation. Thank you.
Oh, you're welcome.
Hey, thank you. Thanks to everybody who participated.
Right. Okay. Bye.